So let's run the project first, and then I'll explain you what I have. So here what I have is this chip. It is a 74LS293. It is a 4-bit counter. So with a 4-bit counter, the idea is that with a simple pulse on the clock wire, we can increment the value of the counter from 0 to 15. And then we can also, with a clock on another pin, we can reset the counter to 0. So what I have here is my 4 LED that represent my 4-bit. My white wire on my NUSBIO GPIO 0 will play the role of my clock, and the NUSBIO GPIO 1, which is green wire here, will play the role of the reset. Now just try to debug it. Okay, now sometimes, I'm going to go this. Now sometimes when you unplug the power and put it back, you get on the counter a random value, which we don't want, which means that when we're going to start the sequence, we're going to have to reset first the chip. So to reset the chip, we simply need to do a clock cycle on the GPIO reset. Let's try that. So I think it's going to be on the high. So as soon as I'm going to execute that line, everything goes to 0. We just reset the chip. And now I'm going to clock on the GPIO 1, therefore clocking 1 pulse and starting incrementing my counter. So here it goes to high, and then it's only when we go to low that we move from 0 to 1. If we try one more time, now here I'm going to go to 2. And here I'm going to go to 3. So now I think we can let it go. And have the full sequence counter. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 0, etc. So, just fun. Nothing very useful with that, though. If you start building your own computer with different pieces, you can actually use NUSBIO and .NET to provide extra functionality like the clock of your CPU and potentially other functionality like reset, which might be good to debug if you really want to see your CPU processing at a very, very low speed.